talking to you guys about electronegativity and ion size, which are related to each other. Forgive my voice, I am recovering from a cold. But before we do anything, I'm going to show you guys how we draw Bohr models. And the rules for drawing Bohr models, it's kind of a way of us visualizing how electrons are arranged inside of an atom. It's not completely accurate, but it is useful. So the first level is going to have 2 electrons, the next will have 8, the next will have 8, and the next will have 18. These are the different levels, and these correspond with the periodic table. So if you ever look at your periodic table, look at how many different elements are in each row going from the top to the bottom. You'll find that they correspond, and there's a reason for this. So if we're doing aluminum, the first thing we do is we look at the periodic table and we see how many protons aluminum has, and aluminum has 13 protons. So I'm going to go ahead and I'm going to write my nucleus here. I'm just going to box it in. I don't want to have to draw all of my electrons out right now. Excuse me, all my protons out. But I'm going to go ahead and draw my first ring around my nucleus, and I'm going to put 2 electrons on it. And then my second will have 8, and I'm going to double them up like this. And then my third will have 3 to get me to 13. And these electrons right here on the outside that I'm going to circle in purple, these ones are called valence electrons. And that's what those are. It's valence electrons. All they are is just the outer electrons. And a full valence shell, a full shell on the outside of an electron is going to be a stable shell. And that means that pretty much everybody, in order to be stable, is going to want 8 electrons. That means that's what we call the octet rule. Octet meaning 8 right there. And it's actually pretty easy to tell how many valence electrons are in each of the elements by just looking at the periodic table. So everybody in this first row right here has 1 valence electron. Everybody in the second column, everybody in the second column has 2 valence electrons. We're going to skip all of these right here because they act kind of strange. And we're just going to keep going. This is 3, 4, 5, 6, 7, and then neon down has 8, while helium is special, it only has 2. So if I asked you what germanium, how many valence electrons germanium had, you would be able to just count over 1, 2, skip a few, 3, 4. Germanium has 4 valence electrons. That's all you got to do to find valence electrons is just count. Now, we're going to draw something called a dot diagram here. And the way we draw dot diagrams is we take the symbol of the element, so I'm going to do carbon right here, and we're going to look at how many valence electrons are based off of the periodic table. And carbon has 4 valence electrons. And I'm just going to go around the block. 1, 2, 3, 4. That's it. That's all it is. You will double up on some of them, though. So if we look at fluorine, fluorine has 7 valence electrons, just from looking at the periodic table. Fluorine, we're going to go 1, 2, 3, 4, but it needs 3 more, so then we're going to start doubling up. 5, 6, 7. That's how it's going to go. Xenon right here, Xe, has 8 valence electrons, and so it's going to end up doing the same thing as fluorine. You'll double up once you've filled all of your sides. And that's how you do valence electrons.